Hello guys, good day. We are here again to discuss a new lesson, and that is solving quadratic equation by completing the squares. Hope you enjoy it. Now we could go over in the content of the solving quadratic equations by completing the square. But before that, we have to understand first the backbone of this topic, and that is knowing its objectives. In working with the quadratic equation with the second degree is not equivalent to 1, so there are some tips or steps that we're going to understand. First step is we are going to be sure that the second degree term has a coefficient of 1. So here, since it is not equivalent to 1, so make it sure that we have to make it 1 as we go through. So by means of this, so whatever the numerical coefficient of the quadratic term, divide that 1 by its numerical value. So that is how the process takes place. Then proceed to step 2. What is the step 2 that we have? So write in correct form. So make sure that all variable terms are on the side of the equation and all the constant terms are on the other side or the right side of the equation. So in short, still the same as what we have done previously. All the variables on the left side of the equation, while the constant term must be on the right side. That is the step 2. The step 3 is we're going to do the completing the square. So how to do it? Recall that we are going to have the linear term, its numerical coefficient b divided by 2. Then whatever the quotient b, to get the constant term is we're going to square the quotient of half the quotient of the half of the numerical coefficient of the linear term. And then the fourth step is we have to solve using the square root property. And take note that if the solutions of the completing the square method are rational numbers, the equations can be solved by factoring. However, the method of completing the square is a more powerful method than factoring because it allows to solve any quadratic equation, wherein, as I said previously, that we cannot solve all of the quadratic equation using factoring because not all quadratic equation can be factored. While here is we're going to manipulate everything on how to solve the certain value of the certain variable. So that is why it is more powerful than the factoring. Okay, let's proceed to the example number 1 for us to be able to enhance ourselves in working with the completing the square, solving the quadratic equation by completing the square, wherein the quadratic term, its numerical coefficient is not the same with 1. So we have here solved for 4x squared plus 8x minus 21 is equal to 0. Then again, try to check first if the quadratic term, the numerical of the quadratic term is not the same with 1. So since it is not the same with 1, so the first step is we're going to divide both sides of the equation by the numerical coefficient of the quadratic term, which is 4. So divide both sides by 4. So we have now 4x squared plus 8x minus 21 all over 4, and the other side is 0 over 4. So as we simplify this, 4 divided by 4 is x squared, 8x divided by 4 is 2x, negative 21 divided by 4 is negative 21 over 4. Take note that that one is reducible, is simplified already, so we remain that one as negative 21 over 4. Then 0 over 4 is 0. The next step is, yes, it's correct, we're going to make it in a point that the constant term that we have, which is negative 21 over 4, be on the right side of the equation. So what we do now here is add both sides by its additive inverse, so which is positive 21 over 4. So that is why the left side of the equation make it 0. So we have, the negative 21 over 4 is 0 now, since we added both sides by 21 over 4. So we have now x squared plus 2x is equal to 21 over 4, because 0 plus 21 over 4, the additive inverse of negative 21 over 4 is 0. So that is why what we have now on the right side of the equation is 21 over 4. So what would be the next thing to do? Yes, we're going to make a perfect square trinomial with respect to this expression on the left side of the equation from x squared plus 2x. So we have to see to it that this one must be perfect square trinomial. How? Then again, I repeat, we are checking first the numerical coefficient of the linear term, so which is 2. Half of 2 is 1. Then square of 1 is still 1. So as you notice, we are adding both sides by the square of its quotient. So 1 plus 1, the other one is also plus 1. But then again, take note that 1 is this, the one here is just the same with 4 over 4. How does it happen? Because we have here the denominator of 4. So take the LCD so that the 1 write it into rational number. So we have here 4 over 4. So on the left side of the equation, so now the left side of the equation rather is a perfect square trinomial now. So we have x squared plus 2x plus 1 is equal to 25 over 4, because 21 plus 4 is 25. Then copy the denominator, which is 4. And after which, since this one is a perfect square trinomial, so we have to factor that. The factor of that is quantity x plus 1 quantity squared is equal to 25 over 4. Then after which, the last step is we are going to use the square root property. So extracting square root for us to solve for the value of x, since we're looking for the value of x. So we have now take the square root both sides. The square root of the perfect square is what is the base here, since the base, the answer for that is the base that we have. Since the base is x plus 1, so on the left side is x plus 1. Then, as you notice in the given slide that we have, it is already break because we have plus minus. So the first one is plus and the other one is minus. Plus a positive square root of 25 over 4, and the other one is negative 25, negative the square root of 25 over 4. So the square root of 25 over 4 is equivalent to 5 over 2, because the square root of 25 is 5, square root of 4 is 2. Still the same here, but then copy the negative sign. So what we have now here is to solve for x by means of looking for the value of 1. We have to see to it that this one here on the left side of the equation make it 0. So what we will do now here is that we are able to transpose the plus 1 here to the other side, or just we say additive inverse, so negative 1, so 5 halves minus 1. Since it is a whole number, so we are going to write this one into a fractional form. So take the LCD. The LCD of 5 halves and 1 is 2. So the least common denominator is 2, so we have here 5 halves minus 2 over 2. And then on the other side, still the same, copy the negative 5 over 2, then transpose the positive 1, so we have here minus 1. So the LCD is still the same, which is 2, so negative 5 over 2 minus 2 over 2. And then 5 halves, or 5 over 2 minus 2 over 2 is 5 minus 2 is 3. Then copy the 2. So the first value of x here is 3 halves, while the other value of x is negative 5 over 2 minus 2 over 2. So we have negative 7 over 2 because negative 5 minus 2 is negative 7. Then copy the denominator 2. So now we could claim that the value of x is equal to set negative 7 halves, 3 halves. So let's continue. Let's proceed to another example. So 3x squared plus 5x minus 2 is equal to 0. Then again, still the same, that the numerical coefficient of the quadratic term, which is 3x squared, has a value of 3. So the first thing that we should do is that, okay, copy the given problem first, which is 3x squared plus 5x minus 2 is equal to 0. Then after which is, since it is equivalent to 3, so divide both sides by 3. All of the equations, all of the terms, both sides of the equation must be divided by 3. So we are now 3x squared plus 5x minus 2 all over 3. On the other side is 0 over 3. Then after which is we have now 3 divided by 3 is x squared because it is equivalent to 1. 5 divided by 3 is, since it is simplified already, so copy the fraction, which is 5/3. Then copy the variable x. Then negative 2 divided by 3 is still the same with, since it is already simplified, so it is equivalent to negative 2/3. Then after this is the constant term, which is negative 2/3, must be on the right side. So we have to work on it, how to make it 0. So that is why we are just added both sides by 2/3. The additive inverse of negative 2/3. So after which, so we have now x squared plus 5/3 x is equal to 2/3. Next step is we have to make it the left side of the equation, we have to make it a perfect square trinomial. How is we're going to have to half of the 5/3. So half of the 5/3 still is, then after that square of the quotient of the result. So as you notice on the right, on the next term of 5/3 x is we have 5/3, the numerical coefficient of the linear term, times half of the 5/3. So we have 1/2, then square. So that is how the process takes in trying to work out with a perfect square trinomial. Then whatever the value on this term here, we're just copied on the right side. Since we are just added here on the left side, whatever to be added here on the left side is still the same. What is the value to be added also on the right side, because accordingly they are still the same. Then we know the fact from this. We now consider this one, since this one is a perfect square trinomial, so we just now have quantity x plus 5 over 6 quantity squared. How does it happen? Because 5/3 times 1/2 is 5 over 6. So as we have here, whatever the square here is the binomial, is the term be put in the quadratic, in the binomial term, for as we take its factor. Since this one is 5 times 1 is 5, 3 times 2 is 6. So that is why 5 over 6. Whatever the half, take note, whatever the half, that is how do we cater it. If this would be minus, the term here also in the binomial term, the factor term also minus. If the linear term is negative. Okay? So we have now 2/3 on the right side plus 25 over 36. Why is it became 25 over 36? Because as we all know that this one is equivalent to 5 over 6 anymore. So the square of 5 over 6, so we have here the square of 5 is 25. The square of 6 is 36. So that is why it became 25 over 36. Then after which is we're going to do the next step, and that is taking the square root. or using the square root property. So the square root of quantity x plus 5 over x quantity squared is equal to plus minus now. Then how it became 24 plus 25 all over 36, because we have the LCD of 3 and 36, which is 36. Then 36 divided by 36 divided by 3 is 12. That times 2 is 24. Then since it is already 36, the denominator of 25 over 36, so copy the 25 over the 25, so plus 25. So 24 plus 25 is 49. Right, it is correct. It is equivalent to 49 over 36. Then we have square root of 49 over 36. So we have the square root of 49 is 7, and the square root of 36 is 6. Then copy the base value of the left side of the equation, which is x plus 5 over 6. Since this is the square root of the perfect square is the base value that we have. Okay? So that is how takes in the next step. So we continue here. We have still the same that I just copied because it is already full in the slide. So from here, as we look for the value of x, so we are going to make the 5 over 6 to make it 0. So that is why it must be transposed on the other side. So as you notice, we have here, as we break down that one, the positive value 1, valued 1, and the negative valued 1. So we have here x plus 5 over 6 is equal to 7 over 6, and the other one is x plus 5 over 6 is equal to negative 7 over 6. Still the same, we're looking for 5 over 6 to make it 0. So the additive inverse of positive 5 over 6 is negative 5 over 6. So we are going to add both sides by negative 5 over 6 as we go through. So that is that the next step takes in. So we have here x is equal to 7 over 6 minus 5 over 6, and the other side is negative 7 over 6 minus 5 over 6. Since they have the same denominators, we are going to work out with the numerator. So 7 minus 5 is equal to 2 over 6. Then since 2 over 6 can be reduced, so we're going to simplify this. So the 2 over 6 became 1/3 now because this is divisible by 2. So 2 divided by 2 is 1, 6 divided by 2 is 3. On the other side is we have negative 7 over 6 minus 5 over 6. So since they have the same denominator, so we have negative 7 minus 5 is negative 12. Then copy the denominator 6. So we have now negative 12 over 6 is equal to negative 2. Okay, so we could now produce the value of x as set negative 2, 1/3. So let's proceed to another set of example for us to then again enhance ourselves in working with a solving quadratic equation by completing the square. So we have an example, 5v squared, solve 5v squared plus 3v plus 1 is equal to 0. The first thing that we should do, since the quadratic term, the numerical coefficient of the quadratic term is 5, yes, it's correct that we are going to divide both sides of the equation by 5. So we have now 5v squared plus 3v plus 1 all over 5 is equal to 0 over 5. Then after that, as we go through, so we have 5 over 5 is equivalent to b squared because 5b squared divided by 5 is b squared. 3v divided over 5 is 3 over 5 because it is simplified already. V, then 1 over 5 over 1 over 5. Then copy the 1 over 5. Then again, the constant term must be 0. So we are going to take its additive inverse of 1 over 5. And that is negative 1 over 5. Then add both sides by negative 1 over 5. So that is why we have that. Take note that what we have here is just to remove the, or make it 0, the 1 over 5 on the left side of the equation, and must be on the constant term must be on the right side. So that is why we have an additive inverse, which is negative 1 over 5. So that is why it became b squared plus 3/5 or 3 over 5v is equal to negative 1 over 5 because 0 minus 1 over 5 is negative 1 over 5. Then after which, this left side of the equation must be perfect square trinomial. How? We are taking the half of 3/5. So 1 half of 3/5. So we have 1 half times 3/5. The square of that. So we have 1 times 3 is 3. 2 times 5 is 10. So the square of 3 over 10 now. So we have the square of 3 is 9. The square of 10 is 100. So that is the 9 over 10 must be added both sides of the equation, since what we are looking here is the perfect square trinomial. So as you notice, we have now add both sides by 9 over 100. So this left side now of the equation is a perfect square trinomial now. So then if ever, what is the factor of this is we have v plus 3 over 10 quantity square, because the half of 3/5 is 3 over 10. So as you notice here, we have v plus 3 over 10 squared is equal to negative 100 over negative 11 over 100 rather, because negative 20 plus 9 is negative 11, because unlike sign. Copy the 100. Then take note that if we're going to go with the next step, we have take the square root both sides. So we have square root of quantity v plus 3 over 10 squared is equal to square root of negative 11 over 100. Take note that if we're looking for the real number value of the variable, so we have no set of solutions since the negative is inside of the square root. So therefore we could now claim that no solution, because the square root of a negative number is not a real number, as I said a while ago. Therefore the solution set is empty or null set.